Hi everybody, today's video is called Two Proportion Z Intervals. In this video I'm going to explain what a confidence interval is. I'm going to review what a confidence level is. You'll see some practice on how to write a two proportion Z interval and some last minute calculator review. Alright, so let's talk about what is a confidence interval. The goal of a confidence interval is to estimate something about the parameter. Remember, a parameter is a number that describes the population. So we may not know something about the parameter, and so we're going to estimate it using samples and statistics. So when we do that, we're never going to really know the real answer, the real parameter. We're going to get a range of values. So you're going to say, I don't really know how many people like chocolate milk, but I think it's between this number and this number. And so the definition says a range of values so defined that there's a specified probability that the value of the parameter lies within it. That specified probability is called your confidence level. The confidence level states it's the probability that a value of a parameter falls within a specified range of values. So again, you don't know what the parameter is, but if you were to continue to do this sampling method over and over again, and you were to compute confidence intervals for all of these sampling methods, if you did a 95% confidence level, that means 95% of those intervals would capture the true parameter. So again, you won't really know what the true answer is or the true parameter is, but you are, with a 95% confidence interval, you're saying that if I were to repeat this, 95% of them would contain the true parameter, even though you don't know what that is. So I think that's pretty cool. All right, so let's do an example. Males and females were asked what they would do if they received a $100 bill by mail addressed to their neighbor, but wrongly delivered to them. Would they return it to their neighbor? Of the 69 males sampled, 52 said yes, and of the 131 females sampled, 120 said yes. Construct a 95% confidence interval to estimate the true difference in proportion of men and women willing to return the money. All right, so we've got two samples here. We've got our males and we've got our females. And success is defined as returning the money. So we've got 52 males doing that and 120 females doing that. All right. And our goal here is to construct a 95% confidence interval. All right, just like before with the one proportion Z intervals, you are still stating your parameters. So the parameter here is not just one, but two different populations. So we're going to define it as P1 and as P2. So we'll say that P1 is the true proportion of males willing to return the money. And we'll make P2 the true proportion of females willing to return the money. And the whole goal of this is to try to figure out what is the parameter. So we're going to write that. We're going to say P hat is used to estimate P. That statement is saying, I don't know what the parameter is, but I'm going to try to estimate it using statistics. Okay? So I think we're ready to check all of our conditions. So the conditions we want to check was it a random sample? Because you don't want to pick the nicest people or the meanest people because that would skew your data. So you want a random sample. You want to make sure that it's a normal distribution so that we can use z-scores. And you want to check that our population is large enough that we're going to get independent samples. You're not asking the same people over and over again. So unfortunately, I didn't say in our problem that it was a random sample, but we're just going to pretend it was, so that for the sake of the problem, because we haven't done them where they're not. So we're going to say people chosen at random. Okay, and then, so we're done there. So to check if something's normal, a distribution's normal, we do n times p is greater than or equal to 10. But this time we've got two populations we're looking at, the men and the women. So for the men, we had, I know you don't have the other screen. Remember, you should be pausing the video and trying these problems on your own and then turning it back on and see if you're getting the same answers as I am. So for the men, we interviewed 62 men and, getting ahead of myself. 52 out of 69 said they would return the money. And for the women, we had 131 and 120 said they would return the money. Okay, both of those bigger than 10, so we're good. Okay, we also need to check the complement. So the complement of that fraction is 17 over 69. And the complement of this fraction is 11 over 131. And we're good there. We're good there. So the distributions are approximately normal. All right. Got 2 out of 3. We're almost done. So now we have to check if our population is large enough. So we have 69 times 10 equals 690 men. And 131 times 10 is 1,310 women. I'm pretty sure there's that many people in the United States. So we're going to go ahead and say that the population is at least 10 times the sample. All right, because everything worked out nicely, we are going to use a 2 proportion Z interval. All right, so let's get started. So we just did state, plan, now we're ready to do the problem. Okay, a 2 proportion Z interval is p hat 1 minus p hat 2 plus or minus Z times the square root of p hat 1 minus p hat 1 over n1 plus p hat 2, 1 minus p hat 2 over n2. And remember, this is exactly like a 1 proportion Z interval, except you're just doing the same thing twice. All right? So in this problem, the men were returning the money at a rate of 52 over 69, which is about 75%. I'd round it a little. And the women were returning the money at a rate of 120 out of 131, which is, let's see, what did I write in my notes? 92. Okay, so now we're ready to plug those numbers in. 75 minus 92 plus or minus. We said 95%, so that's about 2 standard deviations. So it's 75 times 25 over 69 plus 92 times 8% over 131. Okay, and if we simplify this, we get, and that becomes, and so if I were to solve that, I get negative 282 to negative 058. All right, so now we're ready to write our answer. And notice our answer contains 2 negatives. So that means the first parameter is smaller than the second parameter. So the way I'm going to write that is I am 95% confident. And then you're going to write parameter 1 in words. Obviously, don't write that. I'll cross it out at the end. I am 95% confident that the true proportion of men willing to return the money. Okay, so that's parameter 1, so I'm going to cross that out because I don't need that. So I am 95% confident that the true proportion of men willing to return the money. Now we're going to take this answer, and 2 negatives means that the first group was smaller. So we're going to say is between 5.8% and 28.2% lower or less than, and then you're going to write parameter 2 in words. The true proportion of females willing to return the money. Okay, cross that out. I don't need that anymore. So that should just read as a sentence. I am 95% confident that the true proportion of men willing to return the money is between 5% and 28% lower than the true proportion of females willing to return the money. Okay, well, what if we hadn't gotten 2 negatives? What if we had gotten 2 positives? What would that mean? So I've written it out just to save a little time. What happens if we would have got two positives? Had I got, excuse me, had I got two positives, I would have said, I am 95% confident that the true proportion of men who are willing to return the money is, so that means group 1 is larger than group 2 because I got two positives. So I would say is between 5% and 28.2% greater than the true proportion of women who are willing to return the money. Okay, so that's how you write it if you have two positives. If you have a negative and a positive, you'll notice that you got 0 in this interval, which means there's no difference between the two groups. So the way you would write that is, I am 95% confident that the true proportion of men who are willing to return the money is no different. You don't need numbers because you're saying it's not different, so there's no point in writing numbers. So I am 95% confident that the true proportion of men who are willing to return the money is no different than the true proportion of women who are willing to return the money. Okay? So let's go and do the original example using our calculator so you can see how to do this both ways, by hand and by calculator. So I'm going to use the program. So I'm going to go to Stat. Oops, too much. Test. Then I'm going to go down to proportion Z interval. And I'm going to plug in all the numbers I know. 52 men said they would return the money out of 69 men. 120 women said they would return the money out of 131. And we decided we would do a 95% confidence interval. So when you're ready, you've got that all plugged in, you're going to push calculate, and that's the answer that we got. We got a little different, probably due to rounding, because I think we called that 75 and we called that 92, but we're pretty close. So hopefully that helps. Good luck studying for the test, and good luck with two proportion Z intervals. Have a great day.